Nicole Kobie, author of The Long History of the Future, Why Tomorrow's Tech Still Isn't Here. You write that the point of this book isn't to laugh at the mistakes and failings of engineers. Living in the future is excellent. What is the point of this book?
I think it's that we have a lot of technologies, a lot of these ideas that we have been waiting on for a long, long time. And I think that the pace of technology change at the moment is so fast that we sometimes forget that this type of design, this type of development, it takes longer than we think it's going to. It just always does. And, we start to feel a little bit disappointed sometimes that these things haven't happened or may never happen. And I think to a certain extent we should just kind of sit back and enjoy the ride.
Well,
And just wait for when these changes can happen.
well, you write about toiling against the gravity of failure. What does that mean?
It is so easy for something to go wrong. If you've ever tried to build anything, whether it's like an IKEA cabinet or, something a little bit more complicated than that that doesn't come with instructions, it's very difficult to build something. So engineers who are working on these kinds of problems, whether it's driverless cars or flying cars or I don't know, even sillier ideas like hyperloop, they're taking science that we know works and they're applying it to the real world, to a physical object, and then they're trying to build that. And it's kind of in the details where things start to fall down a bit. It's kind of in, you know, how you actually make it happen, the materials you choose, the business model, all of that can just kind of take something that sort of works in the lab or works in an academic paper and just make it completely fall apart, even though, people have spent maybe 80 years on an idea.
Well, you called hyperloop silly. What exactly is a hyperloop and why do you call it silly?
So a hyperloop it's essentially a vacuum train. So the idea is you take a train and you stick it in a vacuum tube so there's, no or very little friction. And that means it takes a lot less energy to move it. And this is an idea that is sort of at the heart of ideas like maglev trains and things like that. And it's a sound idea. It would work, but what it requires is you to build a giant, probably concrete tube. You're going to have to put it in the air, probably. Um, it needs to be, for a hyperloop to make sense, it needs to travel long distances. The idea is that you could go, London to Scotland in half an hour, that sort of thing. Um, you'd then to make London to Scotland work, you'd be able to make a concrete tube in the air across the entirety of the UK. And then it would have to be, vacuum sealed. And then you'd have to have a train that could run in that, and you'd have to figure out how you were going to power that for the bits that did need power. And it technically works. It should work, but it's one of those ideas that just might be so expensive and so difficult to actually build that it doesn't make sense, especially when there are alternatives. We could just build a super fast train and get there in, an hour and a half instead of half an hour. And we know those work and we know how to build them. Um, so yeah, I think Hyperloop is a really good example because you could build one. It just probably doesn't make a whole lot of sense.
Hyperloops is something Elon Musk has been interested in, correct?
Yes, but it's one of the weird projects where he was interested in it. He wrote this very famous white paper or PDF or whatever you want to call it about it and sort of just released it out into the world and said, if somebody wants to develop this idea, then go develop it. He didn't put a huge amount of money into it. They did a little bit. They backed some projects and ran some competitions, but none of his companies actually tried to really build a hyperloop. Instead, they've built some tunnels under Vegas where Tesla cars can go down. And that's kind of as close as he's really gotten to the idea. So he's kind of half on it, half not, if that makes sense.
Where did the name come from? Do you know Hyperloop?
I don't know where the name came from. It's a great name. I mean, it sounds so futuristic. It sounds like a wonderful kind of idea. It's a lot better than just saying, a very fast train. Um, but no, I mean, he must have come up with it, to be honest.
Is The Long History of the Future your first book?
I did do a book before this one about green energy, and that's kind of an inherently future-looking set of technologies as well. So, kind of a bit connected this ways.
How long have you been reporting on tech? You're the futures editor at PC Pro. And was it something that you were interested in, or was it an assignment?
I've always been a bit interested in technology just because I found things like, the early days of the internet when we had to like dial up and all that sort of thing. I found it really captivating, and I thought it was just such an interesting thing where, especially because the pace of change was so fast, that it meant there was always something new. But then when I moved out to the UK, I just needed a job. I just needed any job in journalism, and I happened to get one on a business technology title because at the time, business tech was just where all of the money was. It was very easy to get a job in journalism that paid okay doing that. So I don't have a huge love of technology. I like certain gadgets quite a bit. I like that there's always kind of something new. I love the science and the engineering side of it. Um, but it's not something that is, dear and close to my heart. And I think that actually is probably a good thing for a journalist to have a kind of casual interest in something and not to be too much of a fangirl about it. Because there's a lot of tech journalism that is very, very positive and kind of helps to feed the hype machine. And between kind of my own sort of middling interest and then working at a title like PC Pro that is very full of very cynical British people. British people are very, very cynical naturally, and these people are extremely cynical. It meant that writing about future technologies, we just couldn't help but kind of pick holes in them and be like, we feel like we've been writing about this for 10 years and it seems like nothing has actually changed and that sort of thing. So the book really came out of my work at that magazine.
What took you to London?
I just wanted to do something different. I'm originally from Canada, and London is a very easy place to go to university to get. I wanted to get a journalism degree. It's a very easy place because I'm terrible at learning languages. So I needed to go somewhere that I could, that everybody was going to speak English and it was going to be too tough for me. So London seemed like the perfect place that had English speakers and good connections with Canada and was exciting and had amazing journalism programs because obviously the journalism heritage is, amazing in this country.
Because of the relationship between Canada and England, is it easy for a Canadian to move to London?
In some ways, you wouldn't think that there's a huge cultural difference between the UK and Canada, but there are a few. And just the way that Canadians talk about things, we tend to be a bit more American with our being outspoken. So I have gotten into quite a bit of trouble with opening my mouth and being very direct with things when British people tend to not really say what they mean. So that's something I've had to learn. But I've married a British person, so I guess I figured that one out enough.
Well, back to your book, The Long History of the Future. Let's talk about artificial intelligence. Where did that term come from?
So that term came from John McCarthy. He's an American academic who was working on these ideas in sort of the mid 50s. Um, and they were trying to come up with what to call this kind of new idea of having a computer be able to like think through things and to make decisions and to take actions and to analyze things and all the sorts of things that we assume that AI can do now. And they talked about ideas like machine learning or like, informatics and all these kinds of terms, but they really wanted to have a new term to set it apart from other areas of study because if you don't come up with a new name for it, then it's not really new and you don't get to be the father of AI, you're just the father of something else. Um, and John McCarthy is kind of one of the key players that set up this conference in the mid 1950s, the Dartmouth Conference, and it just brought together, you know, a whole bunch of people working in kind of these areas, computing and what we'd now call AI, and sort of areas around it. And the idea was to get them together for a summer program, and they would all hang out at this university over the summer, and they would make AI. And they were you know, very sure that they would be able to make something that was a thinking, not conscious, but like what we talk about when we think about things like artificial general intelligence. They thought that they would get a real good, part of the way towards solving that problem. And obviously they didn't because we still don't have something really approaching that idea now. Although, we have very impressive systems, we haven't really solved a lot of the problems that they were discussing. Um, so yeah, a lot of the things that we've been talking about around AI kind of stem back from him coming up with this term and from that conference kind of in the mid 1950s.
Now, his colleague Marvin Minsky, that you write about, wanted to call it machine intelligence.
Yeah, and it's one of those things where it seems like it's just semantics and it doesn't really matter. Um, I think machine intelligence is perhaps a better a better way of describing it. And John McCarthy kind of said later on in his career that he wished that they went with machine intelligence because this idea of artificial intelligence, it sort of sets it up to be, against us. And it's something, it's like coming up with a fake human brain and things like that. And that's not really what they were talking about. They were talking about ways of giving intelligence to machines and creating systems that could make decisions and could do something, akin to thinking or decision making. And that machine learning kind of seems a little bit more accurate towards that. Uh, One of the main types of AI right now is machine learning, and that sort of describes it better, I think, and is sort of a little bit of a less hyped and a sort of calmer way of describing it than artificial intelligence, which just sounds, you know, it sounds like something a lot bigger than it often is.
Well, you mentioned AGI, artificial general intelligence. What do you mean by that term?
So defining AGI can be a little bit difficult because even across the industry, people can't really decide what it means. So to me, AGI should be a system that can kind of go out and learn, and it can take decisions and even actions itself. And we have systems that can do bits and pieces of that now, but not this kind of overall machine. And I guess the best way of talking about it is if you think about something like a driverless car. In order to make that work, you've got multiple different systems. You've got a computer vision system. You've got a system that is controlling the vehicle. You've got a system that is pulling in, the camera or the different sensors and all of that. And there's multiple different layers of AI. And to me, an AGI would be able to just, kind of do the equivalent of sitting down in a car and just being able to drive. I mean, even if you don't know how to drive, you can probably kind of suss out a lot of what you have to do, especially in like an automatic transmission car. You kind of point it, and if you see a person in the road, you know you should stop and things like that. You don't have to tell humans all these little details. We kind of just intuit it. We kind of just learn it as we go. And to me, an AGI would be able to do that. You could just give it a task and it would go out and figure it out, and then be able to take those actions. But a lot of people see AGI as something a little bit different and have different definitions. And some of it can be around how intelligent it is. So you get these ideas of super intelligence and being more intelligent than us, or just ideas around being able to make decisions or take actions. And we're beginning to build systems that can take like digital actions that can, click on computer links for us and things like that. So because we don't have a good definition, it's hard to know when we've hit it. But I don't think there's anybody really arguing that we've achieved it yet.
So, in a sense, it's the Holy Grail.
Yeah, I guess it is. It depends what you want from AI, though. Like to me, what I love about AI is when it's applied in a really sensible and specific way to solve a real problem. But then a lot of other people prefer their development to go down a different route and just sort of to explore to see how big how big we can make something and how far can we push an idea. And that's fine. But to me, I want AI that solves problems for people. And we're starting to get that and to be able to solve some actual problems with these systems. I don't, to me, the holy grail for AI would be a system that is safe, that is accessible, that is affordable, that, we can actually use to solve an actual problem and help people. That's not as exciting, I admit, as coming up with a thinking, acting AGI.
Nicole Kobie, you write in your book about AI company leaders whimpering about the risks of a technology they are racing to build.
So there's this idea of existential threat and kind of it gets discussed around this idea of like AI safety and whether these systems are going to be the end of us in a way. So you get a lot of these ideas of like a super intelligent AI. Why would it keep us around if it doesn't need us? If we, there's the paperclip maximizer problem. If we asked an AI to make as many paperclips as possible, it would, take out the entire world doing it in order to make paperclips, just because that's what it was kind of programmed to do or asked to do. Um, that stuff is worth thinking about. Um, this is a serious problem of, how do you control a system that might become very powerful or that might be smarter than us? I mean, when it comes to a lot of problems, these AIs are already smarter than me. I mean, math is not exactly my strong suit, and these systems can all do these advanced math problems. So does that mean that it's smarter than me? But kind of that aside, it's this idea of an existential threat, and that we're building these machines that are causing that threat. And of course, humans have done that before. I mean, nuclear weapons obviously have an existential threat. Uh, the carbon coming out of cars is an existential threat to us. So we have dealt with these things before, or not dealt with them, but created these problems before. But there is another side to AI and the dangers that it creates. And this is sort of the kind of AI ethics side, and it tends to be a lot less dramatic. It's how AI is impacting people when it's being used for decision making, say in governments, or when they use systems to analyze photographs, and they go and make an arrest. Police go and make an arrest based on that, and things like that. And you get a lot of issues around bias and how that's going to impact actual people now. And those tend to be seen as kind of smaller problems, so they're definitely not small problems to the people who are impacted by this. Now, the thing is, if you're the CEO of an AI developing company, you talk a lot about the first part of this. You talk about the existential threat. And our systems are so powerful. They're so dramatically going to change the world that they might actually end the world. I can't pretend that I know what's in these people's minds, but if I actually believed that my technology was going to end the world, I'm not sure that I'd be building it. And there's a belief that perhaps some of this is being over-egged a little bit, and it's almost a marketing thing, is trying to hype these systems. Um, what the truth of it is very hard to understand. I would suspect that some of these, tech leaders see this as a small potential problem that's very, very far off in the future. And in the meantime, they're more interested in getting the funding necessary to keep their existing systems powered, because creating AI is very, very expensive. So, yeah, I mean, the existential threat might be something that 100 years from now, our grandkids are going to have to deal with, or it might be something that these companies are just pushing because they want to make sure that they can get enough funding to keep the lights on. It sort of depends what you think about AI, where you kind of land on that one.
Well, Ms. Kobie, talk about funding a little bit. How much money is going into AI? Is it private? Is it public? Uh, how is it happening?
A lot of it is private, and it's huge sums of money. We're talking hundreds of billions. We don't actually know the kind of hard figures, because a lot of this is sort of private information. But we know that how much, what's gone into some of the funding rounds for these companies, and they're taking, OpenAI is probably, 7, 8 billion to run the company in a given year, and that is mostly it's a little bit salaries, because top AI people obviously are very expensive, but it really comes down to data centers, and having the compute to develop and to run these systems just means you need to have a lot of computers, a lot of GPUs, and that costs a huge amount of money to power. It costs a huge amount of money to cool. And that's where the money is going. OpenAI has a deal with Microsoft because it needed access to Microsoft's cloud in order to do this work. So we're putting a lot of money into this. And when I say we, I kind of mean that widely. A lot of the money is coming from private investors, it's coming from other companies, it's coming from, venture capitalists, that sort of thing. There is some government money in this, of course. A lot of AI development happens in universities, and then university academics go and have very lucrative careers in the tech sector, which is great for them. Um, but right now, the huge AI boom is very much, it's private money, it's privately owned. This isn't something that is open at a university for all of us to necessarily access.
So all these simultaneous efforts, are they being shared with each other? Not necessarily with us, but are these just simultaneous efforts that happen to be happening?
Depends on the project. So some companies are a little bit more locked down than others. Meta, which is the company behind Facebook, is, obviously has its own AI project, and they are sort of partially, they refer to it as open source. I don't think anybody in the open source community sees it as like fully open source, but they release kind of key details about their AI models, in particular around the weights, which is sort of how all of the data that goes in and how it kind of gets analyzed, and is key data to be able to understand how the system works. And they keep that information open. Other companies don't because it's, of course, competitive advantage and it's commercially sensitive and that sort of thing. And that is one of the downsides to having all of this done in the private world means that we don't, the rest of us don't have access to this. Now, some of this could be starting to shift a little bit because DeepSeek, the Chinese company that kind of surprised the entire AI industry a couple months ago, it operates in a more open way. It releases its information in kind of a more open source sort of way so that they want more people using it. They want people to make use of their systems a little bit more. So that might spark a bit of a shift, I think, perhaps for the American companies to try to work in a slightly different way. There's been some discussion that OpenAI might consider that. So hopefully that happens. Another kind of aspect of this is that when it comes to regulation, is regulators would like to know exactly how these systems work. And it's something that's being discussed in the government, especially in the US, is how they're going to take that information that is very commercially sensitive, that is sensitive from a military and a defense standpoint, and make sure that the government has what it needs to know from these companies. So that's a that's a big regulatory question that I think they're still trying to unpick.
Nicole Kobie, is Silicon Valley still the mothership when it comes to AI development? And where else would you recommend that we look?
Yeah, the thing is Silicon Valley has all the money. It has just insane amounts of money floating around. And it has the universities like Stanford. It has all of the companies where all of this is happening, Google and things like that. Um, it's certainly not the only place. I mean, the amount of work that is coming out of China, like since I wrote this book, kind of every single chapter topic area has seen huge innovation from China. And that's because the Chinese government is putting in a huge amount of money behind companies in order to try to keep up with the US and overtake the US when it comes to these technologies. So I think look to China. If you want to see where driverless cars are actually in use, it's either Silicon Valley or it's China. If you want to see where um, flying cars are actually certified, they're going to be in use in Silicon Valley, some bits of Texas, perhaps, um, and in China. Like that's kind of where everything is happening. There's just so much money happening, so much money and so much research and so much development happening in China, coming out of China. I do think it's worth looking at Europe and not forgetting that Europe is still doing all this work because there's amazing research that comes out of the European university network, and a lot of the work, a lot of the application of some of these systems kind of happens in universities still. Some really interesting ways of using AI, for example. Um, and there are some really great projects that are happening in Europe, but they just don't have the money. And they don't, that means that it's a lot harder to keep up with these other projects. So it does come down a little bit to following the money, because that's certainly where a lot of the researchers are gonna do. They're gonna follow the money too.
Well, you write about two Brits who started this whole thing, Ada Lovelace and Alan Turing.
Yeah, I mean, when Alan Turing was working on, you know, his thoughts around AI, and he came up with the Turing test. I mean, I don't think he called it that, but this idea of how to assess AI. He was trying to solve maths problems. He was just taught, thinking about this in kind of an academic way. He wasn't trying to actually build AI because computers didn't really exist. They were still, analog systems that took up multiple rooms. So he was just so incredibly far ahead of the time. And, I think that that's something to remember is that some of the brightest minds in these ideas are in some of the weirdest places. Not that London is a particularly weird place, or Bletchley Park is particularly weird, but that, you know, there's people with potential to impact all of these technologies all around the world, and we shouldn't write them off simply because they're not in Silicon Valley or they don't have access to a Stanford degree.
And Ada Lovelace in the 1820s, what is her role when it comes to technology and computers?
It was a lot around um, kind of programming and coming up with this idea of programming before computers even existed. These people were capable of sitting down and uh, uh, coming up with ideas that are just so far ahead of their time. It's absolutely fascinating, thinking hundreds of years ahead. But it's this idea of coming up with computer programs for when computers not only didn't exist, but couldn't exist because we didn't have any of the necessary components to make them happen. Um, and I think she's just such an interesting case because uh, you know, a lot of that was kind of how computers actually happened and how AI happened in the 1950s was, the people I mentioned before, like John McCarthy, and that they were writing papers about AI and they were talking about what these systems could do, but they didn't necessarily have access to a computer to test their ideas and to write a program for it. They had to just kind of think it through on paper, and then maybe build a computer to make it actually work. It's just such a different set of problems to what, we're trying to solve today, where we can just throw so many um, computers at AI models to try to make them work and try to make them better. And that isn't necessarily the best way. Maybe sometimes we need to kind of take a step back, go back to basics and think about the architectures and the different ideas behind it instead of just this bigger is better kind of an idea.
Hey, Nicole Kobie, when somebody drives by one of those server farms, big building, uh, what exactly is in there and what is it doing?
So these are data centers, and this none of these are new. I mean, the last big computing revolution, for lack of a better phrase, was cloud computing. It was taking all of this data and this processing that was happening, inside businesses and saying, well, we can do it cheaper and more efficiently and just better if we kind of centralize all of this stuff. So, you have this huge warehouse style building, and it's just rows and rows and rows of servers. And that's just a computer. It's just a workhorse of a computer, that have been very specifically designed to do, very, very specific types of work. The thing is, you require a huge amount of energy, and they create a huge amount of heat. If you've ever been using your laptop and it starts to get like really hot, just imagine a building like that. So they have had to come up with a whole bunch of cooling ideas, and a lot of it uses a lot of water, although the industry is starting to finally kind of step away from that and come up with some new ideas. Um, but really, yeah, if you drive past one of those and it's a giant data center, it's just cables and chips and cooling systems, um, in physical form. But it is the internet. It's your Netflix. It's AI. It's all of this, all these, very, core ideas to modern life are that's where they live. That's where all of that happens. And we probably need a lot more of them if we're gonna do this big shift to more AI in our lives.
Well, in your book, The Long History of the Future, you write about two things I wanted to ask you about: NLP, natural language processing, and LLMs, language learning models. What are those?
So, natural language processing is just this idea of, you know, being able to use a computer or any kind of smart machine in a natural way instead of having to type, and to code and to kind of interact on the computer's terms. You just talk to it, and we're very used to that now because I can tell, I can say, "Hey Siri" to my phone, and it'll, you know pop the little assistant up and hopefully it will do what I ask it to do and that sort of thing. And that idea of being able to just talk to a machine and have it understand us is, it sounds like a very simple thing and we're very used to it now, but it is very, very hard to do. And figuring out language is just something that has been so core to one of the potential benefits of AI and to one of the use cases of AI because you know, militaries really like the idea of being able to just take everything that they can get from another country and translate it immediately. So like translation was always kind of a core sticking point and something that, governments really wanted these machines to be able to do. Um, and then LLMs are large language models, and these are the systems that are kind of powering sort of the entire AI boom that happened sort of from ChatGPT onwards. All of these systems, Google Gemini and all of that. These are a machine learning technique. It's a machine learning system, and it's just a way of looking at language that sort of rips apart words and that sort of thing and tokenizes everything. It kind of makes them into little tiny bits and pieces that don't really make sense anymore, and tries to predict what we would want to come next. Um, which is kind of it sort of makes it sound like it's being reduced to autocorrect. But what you can do with that, it turns out, is a lot. You can generate images, you can generate video, you can predict weather. Like I was at a conference a couple weeks ago, and they were talking about new ways of doing weather prediction, and it's just by looking at old weather predictions, they can now predict what's going to happen next. That sort of thing. So large language models sort of sound like they're just about that natural language processing, but they've been applied to just everything at this point. And the big question is, are they the right model type to solve all of our problems, to become AGI? Um, or are they going to prove to be too limited or the not the right architecture or good for some things and not for other things? Um, and I'm not sure that we really have the answers to those questions yet. So it's going to be interesting to see how that kind of plays out over the next few years.
What's your relationship with ChatGPT?
Oh, it is a love-hate relationship. I find it very frustrating to use. It 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 still doesn't come back with what I would consider accurate information. So I've tried all sorts of experiments with it, asking it to do research for me. Go off and find out these pieces of information for me. And it will be right on the most, really detailed points, and then it will get the date wrong on something or somebody's name wrong, or it'll just make up something. And that that's not useful for me. And even if you ask it to kind of like link to things, you link out, you click the link and go see what its source is, and it's like this is just wrong. But on the other hand, it is very useful for search because I have found, Google search and the main search engines like really frustrating lately. They don't come up with what you want. They come up with very old information or something that isn't quite the same thing, and they don't understand basic ideas like not. Like I would like you to find this but not that. So yeah, I find ChatGPT really fascinating to play with and to try to understand. And this is something that I think OpenAI has been brilliant at is anyone who is, listening or watching to this can just go to ChatGPT, sign up for it and use it for free. And it's not their top end model, I don't think at this point, but it's it's free. You can just go ask it some questions. You can just go play with it. You can just go see how this works. You don't have to listen to their marketing. You don't have to listen to their hype. You can just give it a go. And anyone who does do that, pick a topic you know a lot about and see if you can trip it up. Have fun with it. Try to find a use for it. See if you can find a good way to make your life easier using ChatGPT. And I think most people will struggle to find a real use case for it kind of beyond search, but some people will find something amazing to use for it and will really solve a problem. So, yeah, it's fascinating. It's really fun to play with. It's great that it's open for people to just go have a go with it. But I think I think if you really spend some time with it and you really try to get actual accurate information from it, you will start to see that there are still some serious flaws in how these systems actually operate.
Well, since you write about it in the long history of the future, we went in and asked ChatGPT if you're planning to ask Nicole Kobie, a tech journalist, some insightful questions. Here are a few that could spark interesting discussions. Most of them are, basic 101 questions. What do you think are the most exciting technology trends? What are the biggest challenges you believe the tech industry faces? It came up with 13 questions. And I am going to ask you one, and this is a Chat
Okay.
GPT question. Do you think we are heading toward a more centralized or decentralized internet? And how would that change the landscape of technology?
Oh, that's an interesting question. I mean, I think it is already very centralized. I mean, most people use the internet in very closed systems. If it's your phone or you use Google Chrome. I mean, I use Google for everything, so my world is sort of filtered through that. Um, I think it is very centralized, and there's been a lot of efforts to sort of decentralize it because it wasn't the intent to make it like this. And that's where, ideas like, Bitcoin and blockchain and all these distributed social networks and stuff always kind of pop up whenever we get really mad at Facebook. And then they kind of die off and nobody actually uses them, or very few people actually use them. I mean, some of your listeners might have ditched, Twitter/X for Mastodon, but I have not heard a whole lot about that in the past couple of months. So, yeah, I personally would love it to be decentralized. And the wonderful thing about AI is if it plays out the way some people think it's going to, it could make it so that we could all build our own systems and we could all code things by just typing in what we would like, and it will, spit out the code whether we know how to code or not. Um, we're not there yet. A lot of people use these tools for coding, but they have to kind of have the expertise already. So I like the idea that maybe 30 years in the future, everything is distributed because anyone can build anything and it's easy. We could all set up our own internet systems the way we wanted to now, but it's just very hard and probably quite boring. So maybe in the future we'll be able to do that thanks to, these AI systems. But the thing is, these AI systems are all privately owned, privately operated. We're gonna have to pay for access. So we're gonna have to kind of see how that access kind of shakes out. At the moment, you can all go use ChatGPT for free and ask it to come up with something. But if you wanted to do anything more advanced, you're going to be having to have a subscription to it. So I'm not sure that that's the, the answer ChatGPT thought I might say, but yeah, there we go.
Nicole Kobie, you mentioned that you use Google for everything. Google knows everything about you. Is that a fair statement?
Yeah, absolutely. I've hit a point of lock-in with Google where separating myself from my Gmail, from my search, from my photos is possible, but would just be so painful and so time consuming that I just don't do it. And that's, kind of the idea. So I do all of my work in Google Docs. I use Gmail for my work and personal emails. All of my family photos go into Google Photos. So, given they have systems that can look at our images and understand what they are, they, if Google wanted to know, they could know literally everything about where I am, what I'm doing, who I'm there with, all of that sort of thing. What they do with that information and why they would want to do that is sort of a different question. And having the benefit of, European regulation out here, there's some slightly tougher rules around how you're allowed to combine information from different services and things like that. But yeah, I mean, if Google wanted to sit down and just make a profile of me and everything that I do, they would absolutely be able to come up with something that was just terrifying in detail.
Well, even though there are regulations, that information is still out there in the Ethernet or in the cloud somewhere, correct? It exists.
Yeah, I mean,
Are we going to see
it,
that information in 100 years?
oh, I hope not. Um, so there's these ideas around, how we store data and how it kind of degradates and ages and kind of disappears. And I think applying that to a lot of data is very important. So I'm not sure how it works in the US, but in Europe, you need to any Google searches or any internet searches are kept for a certain amount of time because they can be very useful for policing agencies and things like that. you always see these people who get busted for murder, and it turns out they were Googling how to get rid of a body, and it's like, who is still doing that? I mean, you have to know that the police are going to have access to that. Um, but so they keep that data for a certain period of time, but then they must destroy it. So I think it's something like after 18 months that has to actually be truly deleted. But that's just your internet search. There, my inbox for my email has, I don't know, tens and tens of thousands of unread emails that I haven't even looked at, let alone all the ones I have read. All of that is sitting there for them because I don't choose to delete it. Same thing with photos. If I ask them to delete all of my photos, they're supposed to delete them. Whether things actually get deleted and how all of that works and how all of the information that we don't specifically ask to get deleted, what happens to it is a different story, I think.
From your book, driverless cars are here, and they require a driver.
Yes. So here's the thing. A couple of years ago, I took a ride in a Waymo, which is the Google driverless car, and it is absolutely amazing. It's very slick. It's very well presented. It came and picked us up and spelled my name out on the display and things like that. And you just tell it where you want to go, and it takes you off and off it goes. Um, but any of these systems, they aren't 100% driverless in the sense that nobody has any influence on them. So even these ones that are the most driverless, that are truly automated and are out there figuring things out for themselves, they still are connected to kind of home base. They're still connected to Waymo, to Google, so that if they can't figure something out, somebody can do it via remote control. They can kind of take over and say, "Oh, here's what's happening, go that way," or here's you're seeing this van on the side of the road and you're confused by it. That's a van. Just drive past it. It's fine. We don't have good data about how often that happens. With Google's system, it's definitely not very often. But if you are in a driverless car, there is an engineer, back at home base that can take control of your car, that can hit a button and make it do what it needs to do if it's not doing what it needs to do. That's a good thing. I do think that that's a good thing. It does become a problem when, cars lose connectivity and things like that, and that's happened in a few instances, especially in very crowded places. So after a concert or a festival, when everyone's on their phones, how you sometimes can't get a message through and things like that. Well, cars have those same issues and they end up kind of blocking roads and things like that. And if they're autonomous, they shouldn't block roads. They should see that it's busy and they should not go that way. But clearly they're still making some mistakes.
Who was Elaine Herzberg?
So Elaine Herzberg is the sort of first pedestrian killed by a driverless car. And this was in Arizona, several years ago now. And it was a a project run by Uber, and they don't really have a driverless car thing. They kind of spun everything out and sold their technology after all of this. And their cars were driving around Tempe, Arizona. I'm not sure I'm saying that right. And they had a driver, a test driver, at the wheel. But we know from all of the research, and kind of just how humans work with these systems, that as soon as you pass the thinking off to a machine, we stop paying attention. So it's not a massive surprise that the person driving the car was actually looking at their phone. They were watching something on their phone the entire time. And Elaine Herzberg crossed a road at a point where that wasn't an official road crossing. It was late at night, and she was pushing a bicycle because she was a homeless person, and she had all of her belongings kind of on the bike, and she was sort of using it a bit of as a cart. And kind of after all of the investigation, after the car hit her and she died, so there was a massive investigation, of course, and everything that kind of came out of that was that the car's system didn't know what she was. And because of that, it kept relabeling her. So first it labeled her like, as a bike, but that meant that she should have been cycling alongside the car. And then when she didn't do that, it got confused. And it just went back and forth, back and forth, back and forth, into different types of objects, over a few seconds. Um, and because of that, it didn't hit the brakes. And because the system kept hitting the brakes, whenever it saw anything that was confusing to it, they actually gave it a 1 second pause to try to keep the car from kind of, jerking constantly because it was becoming a problem for the ride. So, what all of that kind of combined to is they couldn't, the people who designed this vehicle, who designed the system for the vehicle, it never occurred to them that somebody would be walking across a road at night pushing a bicycle. So the system couldn't figure that out. It just you'd think that it would just say, I don't, there's something here, I don't know what it is, so I should stop or I should change lanes or something like that. But because it was so set on labeling it to try to figure out what the object was to then come up with a response, it ended up just hitting her. And the car, I mean, I think the car, it was like half a second before it hit her is when the car actually started to brake. Um, and a lot about these systems has changed since then. But I think it just comes down to there's a lot of things that can happen on the road, and there's a lot of ways that people react that kind of cause problems for these systems because a lot of it is things that they've never seen before, and they have to try to come up with, meaning for it. Whereas if you're driving, you don't care what that thing is, you just don't want to hit it. You like I don't try to identify what that object is. I just don't drive into it. Um, yeah. So she has the deep misfortune of being, the first pedestrian to be hit and killed by one of these vehicles. And I'm not sure there's even been one since. It's not something that happens commonly because most of where these vehicles are used, if you put your Tesla into full self-driving mode, you're supposed to be on a motorway to do it. And then the vehicles that are driving around San Francisco go quite slowly because they're stuck in traffic and they're on kind of, city roads that have slow speed limits. So yeah, that's kind of what she's known for, and it's quite a sad story, really.
Well, you write about driverless cars that, quote, I find that fully automatic level 5 cars unlikely in my lifetime.
Yeah, I just don't think that we're going to get to a point where all all problems can be solved in all locations easily. And like this is the thing, that Waymo is trying to do. They're trying to take their cars and take them out of San Francisco, which is sort of like their test area, and put them into different cities to see how much of what they've learned in San Francisco can just translate to other places. So, I've been in a Waymo vehicle and it is just deeply impressive. It is amazing what it can do. Um, but it can't do everything all of the time, even in San Francisco, where they've been trained excessively and sort of where it's like their home base. So they try them in different cities, and sometimes it works really well, and sometimes it takes more work. And none of that is, this isn't me being mean to Google or being overly critical. It's just these things take a really, really long time to achieve. And now put it in a place where the weather is different. How do you deal with, I mean, I'm originally from Canada. Um, Driving in snow is way harder than you would think it is. With the city that I'm from, whenever it's the first snowfall of the year, it's just there's so many accidents because all the new people who moved over the summer have never driven in snow before. And these are people with all of our amazing human brains, and they still can't just work this out because it's actually really, really difficult. Then you start going to other cities. I mean, driving in London is just chaos. It's just the rules make no sense. Like I don't drive here. I hate it. It's just chaos. It's an entirely different universe, and they're gonna have to try to make that work. So I think it's very likely that in my lifetime we're gonna have cars that you hit the motorway and you hit a button and it just takes over motorway driving for you. Like that is extremely achievable because there's no people on the motorway. Motorway driving is like a really controlled environment. Um,
Is that level
and it's a
3 or
good it's
level
a good place
4?
for it.
Would you consider that level
Yeah.
3, level 4?
Yeah, absolutely. And I think in some ways we're there in a lot of ways. Level two driverless cars are legal in the UK. I think there's like one car that qualifies for it, and Tesla's, I think, trying to get certified for it. Um,
And level two means the motorway, as you were talking about?
Well, so level two is about certain tasks can be taken by the car. So, lane changing and speed control and things like that. And we have non AI systems that can already do that. I mean, there's lots of safety systems that can manage your speed and can, warn you if you're coming out of the lane and things like that. So this is sort of just taking that step further. But when you get to level four, it's that you can kind of pass over control to the car and you can take your attention away from the vehicle. So if you're kind of level two, level three, you're still watching, you still need to be driving. The idea is that level five, you wouldn't need to have a driver's license. You could just get in the car and it would just take you there as though, it was an Uber with a human driver at the wheel. So that does exist. I mean, it does exist in certain cities in China and it does exist in San Francisco. But the idea that um, I'm never going to have to have a driver's license and I'm never going to have to get behind the wheel ever again, that kind of idea, uh, I don't think is happening anytime soon on kind of a wider scale.
What are cyborgs and BCIs, brain computer interfaces, and are they common?
No, they're not common at all, which is kind of a shame because so these ideas, this is just about taking computing and sort of melding it with people. And this kind of comes into play with AI and Elon Musk and all of that kind of stuff. With the idea that you could put a chip into your head and connect to the internet or connect to an AI system, and it would give you that super intelligence and, make you this like superhuman kind of person. But where this is really, really powerful is for people who have disabilities. If you've had an accident and you've lost the ability to walk, there are, computer mechanical systems that we can put in your brain that could give you the ability to walk. Um, I mean, obviously that's amazing. It could give people the ability to talk or to communicate when they don't have that ability now. But the money sort of doesn't go into that. We've known about this. We've been working on these in some in kind of a trial basis and constantly doing academic research and it's kind of come out of universities and university hospitals and things like that for decades and decades and decades now. And we know that it works. It's just hard to make each system for each person because it's very personalized medicine. So, you know, as these systems kind of come on and become more commercialized and become something that is a bit easier to manufacture and is powered by these AI systems, so they're just easier to build and cheaper to build. Hopefully, we can get to a point where we can solve some of these illnesses. Maybe we can solve something like dementia by putting a chip in your head. And it's not trying to give you superpowers. It's just trying to keep your abilities and to give you back, the ability to communicate or the ability to move. But not enough money goes into it. Not enough research, or I mean, lots of research is done on it, but there's not enough money kind of being put into making this something that is like widely available. So one of the kind of interesting stories that I read about when I was writing this book is around prosthetics, and we've got the ability to make these incredibly integrated smart prosthetics so that if you're missing a limb and they give you a new prosthetic arm, that it's not like you have to think, oh, I need to pick this up. It just becomes your arm and it's, connected into your nervous system the same way your previous limb was. But it's expensive. So it's not something that is easy to get on, through medical systems, whether it's the NHS or a private healthcare system. There's been a lot of efforts to make it cheaper, but just not enough. And this is one of those things that we have billions and billions going into driverless cars and flying cars and AI, and then we have these real solutions that could actually change people's lives, and they're getting grants in the millions instead of the billions. So yeah, I'd like to see a lot more money on cyborgs and BCI, which sounds really out there, but it's really just about fixing very specific problems for individual people.
Nicole Kobie, we've touched on this in discussing your book, The Long History of the Future, but I want to note that in each section of your book, you really go back decades, making sure we know that AI is not yesterday's product. It's been in development, been in development, been in development for a long time, and all the other topics as well.
Yeah, I think it's worth knowing that there's a very long arc to creating these systems. They kind of start as thought exercises in the brains of people like, Alan Turing, and then they become academic research, and then they become something in the lab, then they become something in academic papers, and then a few startups kind of start things, and then you slowly start trying to engineer it and build it, and then you have to start trying to commercialize it and making it a useful thing and making it so that people can actually use it in the real world and figuring out all those kinds of like societal level problems. That's a lot of work. So it's to me, it's not a criticism that this takes a longer than you would expect. Um, but I think there is an issue that, tech companies and journalists who cover these tech companies tend to really overhype something. And it's always, this is going to happen next year. This is going to happen next year. I'm fine with driverless cars taking 10, 20, 30 years to make if that's how long it takes. AI to get to the level that we have gotten it at now took some really key developments to happen. And one of the things that always happens with AI is there's always like a backlash when people find that the system doesn't work as well as they would like it to. Instead of just slowly working on that and slowly improving those things, we just feel like we have to run at it. And then when we don't get immediate results, we just chuck it aside. And like that just really keeps happening with AI. It would be funny if it wasn't so sad. Um, so I would like people to understand that these things do take time and it is okay for something to take time. And, with AI, we've seen a really big leap in capabilities in the past several years. And it's okay to have a leap and then to have some slower, more, sustainable process where we kind of work out some of those societal issues. We work out the little bugs in a system. We figure out maybe LLMs aren't actually the best model, architecture to be using, and maybe there's something better. It's good to go through all of that, and it's not a bad thing to take your time with something. So, yeah, I hope that that's something that kind of people walk away from the book kind of understanding a little bit better.
And unfortunately, we're out of time and we don't get to talk about the flying flivver car of the 1950s.
Oh, it's a good one.
But people can read that in The Long History of the Future, Why Tomorrow's Tech Still Isn't Here. Author is the Futures editor at PC Pro, Nicole Kobie. Thank you for your time.
Thanks so much.
All Q&A programs are available on our website or as a podcast on our C-SPAN Now app.